Okay, hi guys, last video of the unit, video 3-10, see your checklist for when you should watch it. Water is leaking out of a conical tank, of radius 20 centimeters and a height 40 centimeters at a, when you hear the words rate, think about time. So time is changing, so we got to be thinking about rates, and then a question you ask yourself, about time is often when. So when, you want to be looking for rates and when. Those are like the really, really important things about related rates problems. So water is leaking out of a conical tank of radius 20 centimeters and height 40 centimeters at a rate of 15 cubic centimeters per second. So that's the rate that we know. How fast or how slow or at what rate, these are phrases that will indicate that you need a rate. So that's another rate. How fast is the radius of the water changing? Is the radius of the water changing when the radius of the surface of the water is 17 centimeters. So the radius of the surface of the water is 17 centimeters. Okay, so the first thing you want to do is draw a picture and then pick a formula that you know to represent the things that are going on in the problem and its volume, because we're just focusing on cone problems for now. But any formula really. They could even give you a formula you've never seen before. And if the context of the problem is that the variables in that formula are changing at certain rates, then that's a related rates problem. So we've got a cone and water is like leaking out. Okay, and then I'm going to label the picture with anything that's constant, with constants and variables. So don't label something that's a variable a constant. So variable means changing, or subject to change. So only label constants. Leaking. Okay, the tank has a radius of 20 centimeters. I don't put the units in when I'm labeling a picture. And a height of 40 centimeters. Okay. And then we've also got like a radius of the surface of the water. That's a variable. That's R. And then the height. And so we've got V equals 1/3 pi R squared H. You need to know that formula. Okay, and then know what when. So you ask yourself, what do I know, what do I want, and when. We know water is leaking out, so we're having something that's decreasing, so it'll be a negative rate of change. Water is leaking out of a conical tank of radius 20 centimeters at a rate of 15 cubic centimeters per second. Okay, and the fact, guys, that it's cubic centimeters, so you may ask yourself, what does this rate pertain to? Is it the rate of change of the volume? Is it the rate of change of the radius? Is it the rate of change of the depth of the water or the height? Because those are the three variables involved. Well, if you're not sure, look at the units. Cubic centimeters per second. Cubic centimeters, that's volume. So we know dV dt equals negative 15. Careful in a word problem. They're not going to explicitly say negative. They'll say words that imply negative. We want how fast is the radius of the water changing. That was pretty clear. So we want dr dt when the radius of the surface of the water is 17 centimeters. So when this. Then you take the derivative of the equation that you wrote. So I say, so I'm going to go slow. And in these, in these related rates problems, very often the stuff is changing with respect to time. So just changing as time changes. So that's why we say dt. And then plus, this just comes down. Okay, I'm using product rule, just like yesterday. Okay, so the derivative of this is just dv dt equals, now the derivative of that part is 1/3 pi 2r dr dt, h comes down, times. Okay, so this derivative is everything before the multiplication dot, and then the h just comes down, plus 1/3 pi r squared. The derivative of that is 1, and then dh dt. Okay, and then I want dr dt. I want dr dt. Where do I see dr dt? I see it right here. Do I see it anywhere else? No. So I'm gonna carry down the equation, and I'm gonna leave a blank parenthesis for everything except this dr dt. I'm gonna put an r prime there instead because that's easier. It's just less writing. So a lot of times when you switch notation, it's just because it's less writing. So this is 2/3 pi blank r prime blank. Okay, I just commuted and put the 2 there, and then brought down a blank for r. That comes down as r prime. H, I don't know yet. Blank squared blank. Okay, so do I know dv dt? Yes, it's -15. Do I know r? Yes, it's 17 at this moment, not always. Do I know h? No. Do I know r? Yes. Do I know dh dt or h prime? No, I don't. So if you have some blanks that you can't fill in, then you've got to go back to your original picture and use another formula. And in this case, similar triangles also applies to our situation. So I'm moving over here, and I can say that r over, I'll set it up differently than I did yesterday. R over 20 equals h over 40. That's another way of setting up a proportion. Yesterday we did, I did like r over h is the radius number over the height. Okay, so then we cross multiply 40 r equals 20h. And guys, when you're solving for something, you want to solve for what you're replacing, what you want to replace. So what do you want to replace? That's what you solve for. I want to replace h with something else. So whatever you want to replace, that's what you solve for. So I'm going to solve for h, divide both sides by 20, you get that h equals 2r. Okay? So where you had this h before, you can put in a 2r. And good thing we know what r is, so we're going to end up putting 17 in there later and getting a number. But then dh dt, we still don't know, so we could do the derivative here and get dh dt equals 2 dr dt. So h prime equals 2r prime. So in for h prime, I put 2r prime. And then this is -15 equals 2/3 pi 17 r prime, and then 2r, we already know that r is 17, so that's 34, plus 1/3 pi 17 squared 2r prime. Okay. Anything cancel? No, but you could put this, that 2 can go up there. And then I can go -15 equals 2/3 pi, I'm going to factor out the r prime, 17, 34 plus 2/3 r, 17 squared r prime, and then I have to go -15 and then divide by that. And I'll be like, therefore, dr dt. I'm going to solve for I prime, or r prime, and then I'll have this. Okay, so negative 15 divided by, gotta be careful, sometimes people come like all this way and then they mess up in the calculator. So I'm typing it in exactly as it appears on my paper. Plus 2/3 pi 17 squared. Close the parentheses. Did I do that right? Did I do 15 divided by? Yes. Okay, so you end up with this. So it's negative, which makes sense because as the water is getting lower, the radius would be decreasing. 8.3. Now, how is a radius measured? Not in cubic centimeters, but in regular centimeters. And how are we measuring time? In seconds here. So centimeters per second. Okay, guys. Bye-bye.